Hello, hello, hello. In this worked example, we're going to do some simple examples involving position versus time graphs. So to remind you, position we're going to start off by describing what we mean by the position of something in a one-dimensional world. And in a one-dimensional world, position is by definition what we're going to call the signed distance that something lies from an origin, the signed distance from some origin. So the idea is we're going to create some one-dimensional coordinate axis. So I'll draw the axis horizontally, and we'll call this axis the x-axis, and we'll locate some origin. And the units, this is a position, has units of distance. So in SI units, X is going to be measured in meters. And if you have a position with a positive value of X, that simply means that you lie that distance to the right of the origin. So if you had a positive, we'll put a scale here. This is 1 meter, 2 meters. So an object located 1.5 meters to the right of the origin would be located here. And if you have a negative position, you're going to be located somewhere to the left of this origin. So that's what we mean by position. So they say that a picture is worth 1,000 words. Here's an example of that old adage. We're going to graph the position of some object as a function of time. We're going to create a position versus time graph. And we want to pick the position versus time graph that goes along with this story. So the story is there's a person, that's our object. They're initially located at point P. And point P, we see here, has a position of +3 in some arbitrary units, and the person is initially at P, then they move along this horizontal axis to point Q, which is located 1 unit to the right of the origin, and she stays at Q for a moment, and then she runs quickly to R. Position R is at 2 units to the right of the origin, and she stays at R for a moment, and then she strolls slowly back to point P. And the question is, which of the following position versus time graphs correctly represents her motion? So let's approach this a little bit by process of elimination. Let's rule out some choices here that are obvious non-starters. So the person starts at P. P has a relatively big value of position. In other words, P is equal to 3. That's the largest value of position in the story. So we're going to look for graphs in which at time 0, at the beginning of the story, the position is a large positive number. So from that description, clearly choices 5 and 6 are going to be ruled out, and choice 3 is not looking so good either, because the position at time 0 in choice 3 is not as big as it gets. So we're going to rule out choices 6, 5, and 3, just on the basis of that one bit of information. Okay, well, then the next bit of the story is that the person starts at P and she stays there for a moment. Well, what's that going to look like? If you're remaining at the same position, your position versus time graph should be horizontal. You're not changing position, so that results in a position versus time graph that is horizontal. And choices 1, 2, and 4 are all consistent with that observation. Then the next part of the story is the person then moves along the axis to point Q. And point Q, you see here, is located only 1 unit to the right of the origin. So Q is a position that is a relatively small positive number. And so choice 2 and choice 4 are consistent with this observation. It looks like this section here could be located at Q. But if you look at choice 1 here, this position is 0. That's over here. So that clearly doesn't correspond to point Q. So we're going to eliminate choice 1 from the options. So now we have 2 contenders. It's either choice 2 or choice 4 are still possibilities. Let's go on with the story. Person stays at point Q for a little while. Well, that's what's happening in both choice 2 and choice 4. Then she runs quickly to R. Point R is located at a position of +2 units. And the key line here is that she's running quickly. What does it mean to run quickly? Well, that means your position is going to change quickly, and that means that's going to result in a relatively steep section of the graph because you're going to be changing your position rapidly. So if you look at choice number 2 here, this segment here is relatively steep, and that means that she's changing her position rapidly. In choice 4 here, this section is much less steep. So choice 4 really doesn't look like it's consistent with the story. So let's cross out choice 4, and hopefully the rest of the story will be consistent with choice 2. Let's go on with the story. She stays at location R for a moment. Well, that's what's happening here. She's remaining at R at +2 units, position of +2 units. And then she strolls back to P. So if we look at this section here she's at R, and now she's strolling leisurely back to P, point P, and the leisureliness of her strolling is indicated by the fact that this section of the graph is not nearly as steep as this section, and she ends up back at point P, which is where she started out. So the correct answer here is choice number 2. So that's it for this worked example. Hope to see you again soon. Bye bye.